In lesson 4.3, we're going to be talking about function rules and tables and graphs. And functions, again, are those special relations that we talked about in lesson 4.2. A function rule is just an equation. It's just another way of saying an equation. And there's two main parts to these functions. There's an input, which is always your x value, or your independent variable. And then there's your output. And your output is always your y value, which is your dependent variable. And I'll show you what I mean by that in just a minute. So let's look at our first example. The example is y equals 3x plus 4. And they just want you to show the input versus the output. So, input right here determines your output. And the way that you're going to show that is using a table. So, if we had a table set up right here, and we had our x's here, this is a t-chart that you've done in the past. If you were to put some values in for x, your input, you would be able to evaluate and find your output, your y. So let's just try that. If we were to put in 1, 2, 0, -1, -2. So then you just plug them in for x. So y equals 3 times 1 plus 4, and you get your output. 3 times 1 is 3, 3 plus 4 is 7, and there's your output. And you would do that for each of these. So y equals 3 times 2 plus 4. 3 times 2 is 6, 6 plus 4, 10. And you have another output. Independent variable comes from the fact that you choose what numbers go here, typically. Dependent depends on what was picked for x. So that's why those are called independent and dependent. Y equals 3 times 0 plus 4, which is 4. Y equals 3 times -1 plus 4. You might need to do a little math on this one. It's a -3 plus 4, which is a +1. And then try it with -2. And a -6 plus 4 is going to equal -2. Now these form different points that you could plot on a graph if you wanted to. So the points formed here are 1, 7, 2, 10, 0, 4, -1, 1, and -2, -2. And if you notice, this is a function because there's no repeating x value. 1y for every x. There's something you're going to see called function notation this year a lot, and it's really just another way of representing your dependent variable. So don't overthink these, don't try to solve for them. You're actually treating them like they are a y. And what you're going to see is something that looks like that. F of x, sometimes it's g of x, sometimes it's h of x. They use all different letters. The main one you see is f of x. Whenever you see one of these, you're not plugging in a number here and then solving for something or anything like that. What you're basically doing is just replacing y with that. It's really just your y. So you just have to think about it this way. When I have a value for x, evaluate to get y. And here's your example. F of x equals 3x plus 4 when x equals 1. X equals 0. So I'm giving you two different values of x. Here's the common mistake that a lot of kids want to make. They plug in 1 here and they get f times 1 equals, and they start trying to solve for f. That's not what you're doing. What you're basically thinking of here is that this is saying when x is 1, for the function when x is 1, then I'm going to get some value when I plug it in over here. So it's going to look like this. So this is when x equals 1. F of 1 equals 3 times 1 plus 4. You just keep bringing f of 1 down because it's not actually numbers you're solving for. And you're evaluating that side. So 3 times 1 is 3, 3 plus 4, f of 1 equals 7. When x is 1, y is 7. So it basically makes a 0.17. You're not solving for f there. It's just like a y. Same thing when x equals 0. When x is 0, I'm going to plug it in on the right, and I'm going to find what I get. And what you get is 0 plus 4, which is 4. So that's another way to show it, where I just kind of left it out right there. But at the end, I still need to think about that. This is based on when x is 0, which gives me the 0.04. We'll get a lot of practice at that, but just be aware that you are not solving for that variable there. It's notation. It's a way of writing things. It's saying, when I plug that number in over on this side, I'm going to get a new value for my y. So when x is that, y is that. Go ahead and write this down, and then once you've written it down, hit pause. Try evaluating this one. It's what we just talked about. Plugging in the given x value. Remember, don't solve for any of this. Try evaluating it correctly, and when you're ready, hit play to watch the answer. So you should have plugged in 6 for x over here. So when you could really write it as f of x, or you could write it as f of 6 equals negative 3 times 6 minus 10. Negative 3 times 6 is a negative 18 minus 10. And a negative 18 minus 10 is a negative 28. So when x is 6, y is negative 28. Which ends up looking, oops, like that if we were talking about it as a point. Go ahead and write this down, and then we're going to talk about it. This is the other way that they can ask you to do the exact same thing you just did. They're asking you to find the range when they give you a domain. And if you remember that based on yesterday, talking about domain and range, your domain is always your x values, so there's your x values. Your range is your y values. Exact same question, just written a different way. So all you have to do is plug in negative 2 to find what value y goes with that, 0 to find what goes with that, 5 to find what goes with 5. And you'll have 3 different values in the end. Be really careful with your negatives there. So make a little note here, watch negatives. Because remember, Just a little example here when we're plugging in that -2, and most of you are pretty good at this year, but we're going to make sure. When we have something like -x and x equals -2, it becomes a -2, which equals a +2. So just remember that double negative rule when there's already a negative there. So let's go ahead and do this. We should have to do this 3 times. So when x is -2, I get -2 plus 2, which is 2 plus 2, which equals 4. And now I go plug in 0. So when x is 0, I get -0 plus 2, which is 0 plus 2, which is 2. You see how I'm doing that? Now I'm plugging in 5. So I plugged in -2, I'm plugging in 0, now I'm plugging in 5. -5 plus 2, and that's a -5 plus 2 is -3. Once I have those y values, now I know the range that goes with that is 4 to -3. The other way to show this would be through a chart, through a t-chart. So I'd plug in my x's and my y's, and they already gave me the x. So when x is -2, y is 4. So -2, 4. When x is 0, y is 2. When x is 5, y is -3. So that's the way you show it on a table. This is how you would show it if they asked you to find the range. This shows domain and range together. The next thing we're going to look at is modeling a function rule by graphing. So they've given us this function here, and they want us to graph it. You're going to use exactly what we just talked about in order to graph this, and we're going to kind of review t-charts right now, using t-charts to graph, and you did this in pre-algebra. So the main thing is your independent variable, your x, you just plug in any values you want to get y values, and that's going to model that rule for you. The really nice thing is you can pick easier values, so kind of stop and think about some of the values that you could pick there. So you put your equation in the middle. That's where you're going to evaluate. Your independent variable goes over there, your x values. Your dependent, your answers, go over here, your y's. So you get to pick numbers. So just kind of stop and think about some easy numbers that would be nice to plug in. Something like 0. 0 is always nice to plug in. Now, you have a fraction here. For me personally, even though 1 is usually an easy number, now I've got a fraction still. What I would look for is numbers like 2 over 1, 4 over 1, 6 over 1, 8 over 1, even numbers that are going to allow this 2 to cross-cancel, and then I don't have to deal with fractions. So I would go ahead and go with 2 as my next one. Let's just start with both of those. So we plug it in, we get y equals -1/2 times 0 plus 1. -1/2 times 0 is 0. 0 plus 1 is 1. So your output is 1, or your dependent variable is 1. Now let's try it with 2. Y equals -1/2 times 2 over 1, because that's the same thing, plus 1. Negative times a positive is a negative, and this becomes a 1, so I have -1 plus 1, which ends up being 0. So I took up 2 lines to that one, which is fine. Okay, now I'm going to plug in another one, like -2. So y equals -1/2 times -2 over 1 plus 1. The negative times negative becomes a positive. 2 over 2 becomes 1. So we end up with 1 plus 1, which ends up being 2. Now you have your 3 points, and typically you want to go with 5 points, but for this example I'm just going to stop at 3, and we can practice more later. So your 3 points are 0, 1, 2, 0, negative 2, 2. Now when you go to graph that, we're going to plot the points 0, 1, 2, 0, negative 2, 2. And then we're going to connect them, and we should have a linear equation, which I'll explain more about in a minute. Arrows at the end showing all possible solutions. I could have plugged in any of these numbers along here and had an answer that would fit somewhere along this line. So that's showing all of the possible solutions there that we could have plugged into that table that we did at the top. Now, notice the domain and range here. On an equation like this, is there any x value that you could not have plugged in to get a y to go with it? If you think about it, that's just going to keep going on forever and ever and ever and ever and ever. So your domain on these linear equations is just all real numbers. You can plug in anything, it doesn't matter. Any real number, and you're going to get a y that goes with it. Which also means your range goes forever. So in this case, your range is also all real numbers. And that's common for linear equations, unless they have some type of real-life application on them where they stop at a certain point. Go ahead and add this to the left side of your notes, and then when you're ready, hit play again. It's just talking about what we talked about right here. You're setting up your t-chart, you're choosing your domains, choose wisely like we did here, we didn't choose one, and then evaluate to find your range, your y's, and then you graph them, and that's it. There are some main types of functions that you're going to come across this year, and their graphs always look very similar. So I'm going to go over those right now. The first one is when you have just an x in equations, an x and a y, and it's not squared or anything like that. And that's what you just saw, and that's linear. It's always going to be a line. The second type, which we're going to talk a lot about in second semester, is when you have an x squared. And when you have x squared, that is called quadratic. And the type of graph that you're going to end up with is called a parabola, which again you'll see a lot of in second semester. It's like a U shape. Looks like a U almost, like that. Or it opens down. And then the third type that you're going to see a lot of is the absolute value of x. And the absolute value types end up looking a lot like the parabola sometimes, but you have to be careful because they actually have a point on them. They're like a V shape. And we could talk more about how that works as we graph them. With linear, 3 values is usually enough. You can pick 3 domains to make sure you're doing it correctly, to graph and evaluate. But with the others, with any others, you always, always, always pick 5 domains. to find range. Okay. And you always need to pick some, I shouldn't say always, but a lot of times, some positive, some negative. And again, as we go further into this, I'll explain to you why later. But for now, you always want to pick a couple positive, a couple negative, and probably 0. So let's go ahead and graph another one, just like we did the last one. It tells you to graph absolute value of x plus 1. So because you see absolute value, you should automatically know your graph needs to be a v in the end. So you're going to do exactly what we did in the last one. You set up your chart. Absolute value of x, oops, sorry about that, plus 1. And this is y equals. So your x's are going to go here, your y's are going to go here. And ignore that. I accidentally put absolute value around the whole thing. So again, you pick the values. You need some positive, some negative. I always like to start with 0. And then I might try 1, negative 1, 2, negative 2. I'm at 5 points. So now I can plug them each in. So y equals the absolute value of 0 plus 1. And the absolute value of 0 is 0. 0 plus 1 is 1. Y equals the absolute value of 1 plus 1. And the absolute value of 1 is 1. 1 plus 1 is 2. Then I plug in the next one. The absolute value of negative 1 is 1. 1 plus 1 is 2. Next one. Absolute value of 2 is 2. 2 plus 1 is 3. And the last one. Absolute value of negative 2 is 2. 2 plus 1 is 3. Notice you got the same answers here, and you're going to see why once we go to graph this. So again, here's your points. 0, 1 is your first point. So 0, 1. Your second point is 1, 2. Third point, negative 1, 2. Fourth point, 2, 2. No, 2, 3. Fifth point, negative 2, 3. And then you put them together. This is why you needed some positives, some negatives, so that you can have that full V shape. And it's a V shape because if you think about it, these are exactly across from each other every time. It's not a slow sloping change. These are automatically swapping. It's like a linear equation and a linear equation meeting and stopping because of that absolute value. Now, what happens with this, if you notice, is that you could keep plugging in x values and this will just keep growing forever. And you could keep plugging in x values here and this will keep growing forever. But there's a limit. No matter what happens, it's always going to keep growing up. Notice it's never going to go down below here. That changes your range. So in this case, your domain is still all real numbers. But it's your range that's a little tricky that you have to be careful of. Your range in this case, we're going to use this special format. Y such that y has to be something. Notice all your y values go up from 1. And we just talked about inequalities in our last chapter. So we know all y values need to be at least 1. So they have to be greater than or equal to 1. and that's how you write the range on those. If it had been opening down, then you would say y's are less than or equal to 1. And we'll go over those more because they can be a little confusing sometimes. Now there's times they're going to ask you just to find the domain of things and to look and to see if they are relations or not. And then, if they're functions or not. So you really want to get in the habit. Like right here, I see I have an x alone and then I have a y. I already know this is a linear equation because I have x, y, it's not squared, there's nothing else going on with it. So right away I know this is linear. I could sit there and plug in some values and try to figure out if it works or not, but I already know it's going to work. And I already know that all linear equations have a domain of all real numbers because I can plug in any value of x. So I just get to write my domain is all real numbers. And then is it a function? Well, yes, linear equations are functions. So yes, it is a function. There's no repeating x's. All right, let's try another one. Y equals 1 over 3 plus x. These are just the different types you could come across. Okay, you should all know a rule about denominators by now. So hopefully you thought about the rule, and it is that what's in your denominator cannot equal 0. X can be 0 because 3 plus 0 is 3, but the denominator can't equal 0. So think about that for a second. But we can't have 0 in a denominator. And this is how you figure these out. You just try to set this to equal to 0. 3 plus x equals 0, solve for x. Obviously, most of you could do that mentally, but in case it was something more difficult, that's how you figure it out. Now, this is not your answer. When x is negative 3, this becomes 0. So, it can't be this. It's not that it's your answer, it's that it can't be that. And the way you're going to show that is you're going to say domain x such that x cannot equal negative 3. So that's a not equal to sign. But then, once you start plugging everything in, you're never going to have a repeating y. I could plug in 4 here, I could plug in 5, I could plug in negative 4. I'm never going to get a second value for y. So this is a function. Alright, let's look at one more. X equals y squared. It's not an x squared. An x squared would have been one of the parabolas we talked about. Stop and think about a number that you could plug in here that could actually be two things here. We're trying to look at it for a counterexample. So something like 4. If this was 4, y could be 2. Y could also be negative 2, because negative 2 squared would be 4, 2 squared would be 4. That's two values of y for one x, not a function. So you would just put not a function. This would be like one of those U's that opens sideways. And in case you didn't understand, I'm going to put x equals 4, y can equal 2 or negative 2. Which means we'd have 2 points. We'd have 4, 2, and we'd have 4, negative 2, which is a repeating x. Now your domain's a little tricky in this one, but you'll get better at these as you look at them. So domain is x such that x is something. no matter what you plug in here, any negatives that you end up plugging in, because they end up multiplying by themselves, they all become positive. So you're never going to have a negative x in the end here. Everything ends up being positive, which means all your x's are always going to be greater than or equal to 0. They can't be below that. And for example, if let's say y was -2, when we plug in -2, it becomes a +4. So you're never going to go below 0 on those. And that's this lesson.